Now, quadratics are my absolute favorite. I'm going to share this with the world. Just give me a moment here. Brilliant. My absolute favorite, quadratics. Oh, delicious. Quadratic inequalities. Just to get started, as a little appetizer. Okay, let's see. So, we have the graph y is greater than negative x squared. So negative x squared has the origin point 1, negative 1, 2, negative 4, and it's symmetric. It's a parabola that opens up downwards. So let's see now. It'll be about here-ish and here-ish. Okay. But I must remember that it's a dashed line for an inequality. Something like that. Okay, and now to check what side of the parabola to actually shade in. So I believe it's this side. That's just my gut talking, but I've always got to do the test. So what do I test? Well, I test with 0, 1. 0, 1. Because the x value is 0 and the y value is 1. And so it's so easy to check. You plug in 0 where x is, you plug in 1 where y is, and you see if it's true. Is 1 greater than 0? It is indeed. Beautiful. Okay. Y is greater than or equal to 3x squared. All right, so that's going to have the origin. It would be 1, 1 if it were just regular old x squared, but it's going to be 3 times higher than that. So 1, 3. Instead of 2, 4, put 2, 12 and make the whole thing symmetric about the y-axis. And there we go. This will be a solid line. Something like that. It's very hard to draw curves correctly with this writing thing. Okay, now to test the points. So I could go with 0, 8, for example. Wait, did I do that right? Uh-oh. Pretty sure I did that right. Oh, yeah, I remember now. Okay, so yes, so it'll be inside here. Okay. Y is greater than 2x squared. So instead of 1, 1, it's going to be 1, 2. Then instead of 2, 4, it's going to be 2, 8. And symmetric about the y-axis. Just like that. Origin as well. And a dashed line. there. And every point here. Y is greater than or equal to negative 2x squared. All right, so that's very similar to before. And checking now. Well, for 0, 1, yeah, that's fine. Lovely. Okay. Well, how about this one? Okay. Need to find the roots of this. So what? 2 and 6 don't work. Neither do 3 and 4. I tried the discriminant, b squared minus 4ac, and I get 36 minus 48. 36 minus 48. So it has no real roots. It has no real roots. And therefore it's sort of floating above the x-axis. And now to find its line of symmetry, so you use minus b over 2a. So in this case, it would be 6 over 2, so 3. So the minimum point would be found by inserting 3. So 3 squared is 9, take 18 is negative 9, and plus 12 is 3. So that's what it looks like. It's a quadratic that opens upwards and has a minimum point right there. But I like to get things right. So let's put in 4. Okay, 16 take 24, that's negative 8. Negative 8 plus 12 is 4. So there it is. Plug in 5. 5 squared is 25. 25 take 30 is negative 5, and plus 12 is 7. And it'll be symmetric about the line of symmetry. And the y-intercept is going to be off the screen. So something like that, I believe. But we'll check all this at the end. Now, y has to be less than or equal to this. So you can just see by sticking in the origin, it turns into 0 on the left and 12 on the right. And is 0 less than or equal to 12? It is indeed. And so the origin is included. So it's everything underneath. Just like that. Next up, we have this one here. So I'm going to times both sides by negative. No, I'm not. Well, I'm going to do the whole discriminant thing. Okay, b squared minus 4ac. So 64 minus 4 times minus 2 times minus 9. Okay, that's a lot of minuses floating around. So it all collapses down to a single minus. So 64 minus 72, which is negative 8. So this won't have any real roots either. It will be below the x-axis, something like this. Okay, so, and in fact, we kind of already know that it passes through 9 by just plugging in 0. And what else? Well, we want the line of symmetry, which is minus b over 2a. So that'll be 8 over negative 4. And 8 over negative 4 is negative 2. So it's going to be here, the line of symmetry, and you can plug in -2. Square it, you get 4, times by -2, you get -8. Then add 16, so 8, and then take 9, so -1. So there, that's what it'll look like. Now, how about plugging in 3? All right, so -2 times 3 squared, so that's -18. -18, take 24 is -42. Really? Oh my gosh. Am I completely wrong there? Probably I'm doing it wrong. Let me try again. Uh-oh. Where am I going wrong here? Probably I should slow down. Okay, so that's right. Okay, so that's fine. So where am I going wrong with this? Huh? What's going on? Oh my goodness me. Oh my goodness me. Why does the brain do that sometimes? Look at that. Minus there, plus there. Of course. I'm on the wrong side. It's like I'm driving on the wrong side of the road. That's funny. Okay, so plug in -1 now. Fix it. Okay, that's better. There. Sanity is restored. Okay, so here we go. There. Now, what side to color in? Plug in the origin and we get is 0 less than -9. No, it is not. There. Next. Just do b squared minus 4ac. So 36 minus 48. So again, it's going to be underneath. This line of symmetry minus b over 2a. So 6 over -2. So -3. Okay, plug that in. -9 plus 18. Just regular 9. And regular line, take 12. Well, that's minus 3. Okay, so here. Right. Now what? Put in minus 2. Minus 4. Plus 12. That creates 8. And 8 minus 12 is minus 4. So there, and I'll plug in minus 1. Okay, so minus 1 plus 6, that's 5. 5 minus 12 is minus 7. And that seals the deal. Okay. Now, all right. There. Last one. Just do the line of symmetry straight off the bat. So 3, all right. Now plug in 3. 4. Okay, there it is. Now plug in 2. There. Plug in. Wait, is that true? Anyway. Okay, so now plug in 1. Right. I see. Of course. Of course. It's like a regular quadratic because it's monic. That's all I had to do this whole time. Anyway, so it's everything above, but if you plug in the origin, you can see that's not true. So there you go. And now to check. Everything must be checked. Okay. All right. And all correct. Okay. Oh, I love completing the square. Let's see how many. 30. All right. So like that. But if you do this, then you expand it out, you get 361 on the end. So C would be 361. Likewise over here, 256. And over here, it would be negative 5 over 6. And when you square that, you get 25 over 36. Okay, I'm at 12 all squared, so it's 144. But I'll check the first 4 to make sure I'm on track. And it's all correct. Good. So 49. Okay. That. 12 22 over 26. So 11 over 13. So 121 over 169. All right. Okay. Minus 17 over 2. So 289 over 4. 21. 17. Minus 5 over 28. So 25 over 74. Yes. And now minus 11 over 24. 576. And that. And hold on a minute. 5 over 38. So this. And 2 over 5 comes 1 over 10. So is that right? But I thought I made this error earlier. Here. Okay, so negative 1 over 10. No, negative 1. Oh, so this is an error. Okay. Okay, so and here and here and here. Wait. This is assuming things about signs, which I don't know for sure. Okay. This this is suspect. Check the first 20. Okay, so they are valid and valid. Continue. Therefore, that's not right. There. And there. And check. You must always check. And it's valid. Correct. Okay, so now solving quadratic roots, I believe. Okay, but just before this, have a sip of water. Only 28? Oh. Solve each equation by taking square roots. Now, to begin, here k is plus or minus root 76, and that's 4 times 19, didn't you know? So plus or minus 2 root 19. Here's plus or minus 4, and here's plus or minus root 21. As for here, plus or minus 2, but we check. Must check. And it's valid, but they didn't want an exact solution. They didn't say that, but that's fine. So, plus or minus 2 root 5, negative 72. So this is actually imaginary solutions. So 6 root 2. Like that. And here we go. M squared equals what now? 69. Is that true? Well, 6 times 70 is 420. All right, so it is 69. Well, fine. And here, there. Check these, please. Oh, we're not admitting complex solutions? Well, that's just a spoil for the show. Plus or minus 9. Plus or minus 10. And divide it now. Plus or minus 8. And 9. And root 78, which is, don't you know? No, I don't know. I can't do that any further. All right, plus or minus. Hold on now. There. Plus or minus 1. Plus or minus 6 root 2. Indeed, here, 290. Divide by 10. So plus or minus root 29. 200. Plus or minus 10. Oh. Here. 495 over 5. 495 over 5. Well, wouldn't that be 99? Seems so, right? And here, 312, and divide that by 8. We're dividing that by 8 to get 39. Add 10 over 48. So, plus or minus 4 root 3. 536. Divide that now by 8. So you get what? Uh-oh. So, 67. Oh. 324. Well, that's 18 squared already, but we divide it by 4. 324 divided by 4 is 81. So plus or minus 9, of course. And 7, 25 plus or minus 5 then. And here. And here. Okay, so we'll only have integer solutions for some of them. And a bunch of approximations, but we're kind of out of that habit now of decimalizing. So for the ones that do have integer solutions, great. Now, to solve the quadratic, solve each quadratic by factoring. How many here? 22, you say? Okay. Notice that a lot of them are already factored. So we can just say -1 and 5, -1 and -2, -1 and -5/4, -3/2 and -3/4. Here we are mandated to factorize this one, so add on 5 to both sides. You get x squared take 11x plus 24. You factorize and you get x take 8 times x take 3. As for here, 5, and then that's equal